Dear students, in this example, I'm going to explain the concept of rank correlation coefficient for repeated observations. Here, the data is given for two variables x, y and is asking to calculate rank correlation coefficient. As we know that rank correlation coefficient is calculated by rho is equal to 1 minus 6 summation of d square by n into n square minus 1. So this is the formula we use when the observations are not repeated. Okay, but when the observations are repeated, then we need to give average ranking. So this formula will be changed. So I will come back to the formula. First of all, let's give the ranks for both x, y. Okay. So we have 8 observations. So let's take 1, 2, 3, 4, 5, 6, 7, 8. So from x, the highest is 80. So 80 will be given first rank. So first rank is over. After 80, the next observation is 60. Next highest is 60. Will be given second rank. Second is over. Next is 40. 40 will be given third rank. Third rank is over. Next highest is 28. 28 will be given fourth rank. Fourth is over. Next highest is 20. But we have two 20s. So that's why when we have repeated observations, that is 20 repeated for 2 times, so we need to take next 2 ranks, that is 5, 6, and for this 5, 6 we need to take average. So for 5, 6 average means 5 plus 6 by 2, that is 11 by 2 means 5.5. so that's why for this we give 5.5, for this we give 5.5. but do remember 5, 6 ranks are over. So the next highest will be given 7th rank. So next highest is 15, so this is 7th rank. And next is 12, so we will be given 8th rank. So these are the ranks for variable x. Similarly, let's work out for ranks of the second variable y. Again take 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now again same logic. The highest observation is 60, so will be given first rank. So first rank is over. Next highest is 50, so 50 will be given second rank. So second is over. Next is 40, so third rank. So third is over. Next highest is 35, so 35, fourth rank is over. Next is 30, but 30 is repeated for 2 times. So that's why we need to take next 2 ranks, that is 5, 6. Again average of 5, 6 is 5.5. So here it is 5.5, here it is 5.5. And next is 20, 7th rank, and 10, 8th rank. So like this, we need to complete ranking process. After that we go for D. D means deviations. Deviations are nothing but the difference between the ranks. So here in this example, the difference between R1 and R2, that means 7 minus 3, that is 4, 5.5 minus 5.5, 0, 4 minus 2, 2, 8 minus 5.5, that is 2.5, 3 minus 7 minus 4, 2 minus 8 minus 6, 5.5 minus 4, 1.5, 1 minus 1, 0. And d square values are, d square means squares of d, that means 4 square 16, 0 square 0, 2 square 4, 2.5 square 6.25, minus 4 square 16, minus 6 square 36, 1.5 square 2.25, and 0 square means 0. Okay. But as per formula we require summation, so summation of d square. So sum of all d square is 80.5. Now as I said earlier, the rank correlation is calculated by this formula. But if you observe the ranks, we have average ranks, or else we can say we have repeated observations. Therefore, this formula will be changed. Now, because of repetitions, the correlation coefficient rho is calculated by 1 minus 6 brackets open summation of d square plus another new term will be added, correction factors divided by n into n square minus 1. Okay, so this is the formula. So here we have a new word called correction factors. Then how to find out correction factors, and for what observations we need to apply correction factor. It's very simple. Whatever observations were repeated in both x comma y, only for those observations we need to apply correction factor, and correction factor is calculated by m into m square minus 1 by 12. This is the formula for correction factor, where m is nothing but the number of repetitions. For example, under x 20 is repeated for 2 times. So while calculating correction factor for 20, m is nothing but 2. Whereas under y 30 is repeated for 2 times. So while calculating correction factor for 30, m is equal to 2. So correction factor of the first repeated observation, that is 20, is m into m square minus 1 by 12. That implies here 20 repeated for 2 times, so 2 into 2 square minus 1 by 12. That implies 2 into 2 square minus 4, 4 minus 1, 3 by 12. That means 6 by 12, that means 0.5. Similarly, the second observation which is repeated is 30. So correction factor of 30 is, so this is also repeated for 2 times, therefore again 2 into 2 square minus 1 by 12. So if you simplify this, you will get 0.5. So this is one correction factor, this is one correction factor. So therefore rank correlation rho is equivalent to 1 minus 6 brackets open. If you see this formula, summation d square. What is summation d square? 80.5. 80.5 plus correction factors. This is one correction factor, this is one correction factor. So 0.5 plus 0.5 whole divided by n into, n means number of observations, 1, 2, 3, 4, 5, 6, 7, 8. That means 8. 8 into 8 square minus 1. So this implies rho is equal to 1 minus 6 into 80.5, 81.5 divided by 8 into 8 square means 64. 64 minus 1, 63. This implies 1 minus, so 6 into 81.5 is 489, divided by 80 into 63 is 503. This implies 1 minus 489 divided by 503, which will give you 0.97. This implies 1 minus 0.97 is equivalent to 0.03. So 0.03 is rank correlation coefficient between the values of x comma y. That's it. Thank you.